Hello, Malaga. Are you all excited about this talk? How's the conference? Great. It's been amazing. So I'm going to talk about chatbots for the next 50-ish minutes, 40 minutes, and then we'll have some questions. Can't really do a live code demo because my laptop doesn't like cables anymore, as it turns out. So what we'll probably do is, if you want to see something live, we'll do a kind of private session afterwards. So just like outside somewhere, and then I'll just like show you some cool code. So let's get started. I'll do a quick introduction of me, and then I'll do an introduction of the framework, and then we'll proceed from that. This talk's mostly going to involve a lot of patterns and a lot of practices that we've extracted over time. So it's implementation agnostic, so you can use these practices in any kind of implementation that you want. So quick introduction of me. I'm Manthan, as you already know. I work at Capital One. I'm one of the principal software engineers on services, so I work on mostly backend stuff. I used to work on full stack, but they kind of subtly told me that you should work in backend, so I work in backend. I was part of one of the first 12 software engineers in the company, so we started a department called Software Studio. We're doing lots of work in-house now, and we're doing everything from scratch, so that's like cloud stuff and everything. So as part of a kind of the company culture, we have this thing called 10% time, so I get to do stuff that I want to do in my own time every Friday afternoon. It sometimes overlaps into a whole Friday, but it's not really that strict. So as part of that, I have a secondary project, and the secondary project was chatbots. I've always been quite curious about kind of like how does intelligence work at a conversational level. So if you ask a question to something, how can you make it respond with empathy, and how can you make it respond with context, and not just a static response, because that's what you would get in kind of those bad voice machines, because they will always say like, I hope you have a nice day, but it doesn't really mean that you have a nice day. So it has no meaning. So how can you make things understand what you're trying to say? How can you make things understand the context, and also how can you make it respond in kind of better way? So I've been doing that since I graduated. So I graduated from London. I wanted to do chatbots as my final year project, but I didn't really know much about it at the time. So again, I got subtly told that I shouldn't do that. I should do something else. So I did a different project. It was a big data Hadoop type project. And the chatbots it was on a back burner since then. It kept going. And as part of that, over years, I extracted a couple of principles, and I put them on a framework called Talkify. This is an open source framework. This is one implementation of those principles. If you look at a couple of readmes, those readmes outline the patterns and practices. It's not really. It's not that you have to use the framework for it. You can write your own framework. You can write your own implementation of those patterns. But this framework is mainly geared towards kind of how do we make chatbots enterprise ready. So like how do we make chatbots work in an enterprise, scalable, highly available, and all that kind of stuff. I wouldn't claim that I'm a data scientist. I am a software engineer, so my take on chatbots has been quite a software engineering viewpoint type thing. So if you think about it, think of like 10 years ago when web was a big thing and you had to make websites. It was absolutely painful to write a website because you had to deal with raw code, and then you had to kind of just try and host it on a server. You had to do that awkward Apache thing with like var dub thing, and it was really terrible. So, but with new frameworks and new tooling that came out, it made doing that really easy. So that's kind of the goal with this framework. So how do we make chatbots as easy as making websites? Now, if you have a Amazon account on S3, you can just drop a massive website and it gets deployed in within microseconds. You can do a couple of DNS things with, if you use something like Heroku, you can do that. And again, it takes a couple of seconds now rather than taking a couple of days to do that. So it's really about how do we make things more intuitive, and how do we make things into concepts that can be grasped easily. And that's what this framework represents. So a quick check. How many of you know JavaScript? Aha, amazing. How many of you know Express? So the Express.js framework. Excellent. Okay, this is going to be a lot easier. Oh, that's it, I think. Okay. So the learning objectives here, we're going to go through 3 things. We're going to go through the anatomy of a chatbot. We're going to go through, so the anatomy is going to include what the basics are. We'll probably look at a quick example of kind of how to build one. And we'll look at some of the advanced concepts. The thing about how to build one, I was actually going to do a live demo, but what we'll probably do in place of it is we'll just kind of look at what are the bits that are involved, and then we'll see how you can externalize those things into a different code, and how you can make those things highly available and a bit more intelligent, a bit more contextual, and a bit more natural languagey. And the third part is the advanced concepts, which is going to involve some of the stuff that will help you take your chatbot from being a chatbot to being like a personal assistant, and being much more than just a chatbot. So yeah. So the first thing is the anatomy of a chatbot. Now, this is the next image that you'll see is basically what a chatbot is, right? It's this. You've got 3 separate layers that you can work with. You've got context resolution, then you've got classification, and you've got a skill. Now, arguably, this just represents what a chatbot is. And the reason why I keep saying a chatbot and a chat assistant, there's 2 different definitions of those. A chatbot is something that you use where on kind of something like Facebook Messenger. So you use like Domino's chatbot where you tell it exactly what you need and it will answer you and it will do stuff for you. It's really like a Q&A type thing. You're asking it a question and then you're then kind of interacting with it in a very defined way. You can't ask a question about life and universe to a Domino's chatbot because it would just get really confused. It might tell you about the whole meaning of life and universe is a pizza, but that's not really a good answer. For a chatbot, this is quite sufficient, but then what we'll see as we go forwards is how you can take these layers apart and then make them grow depending on what you need. So if you need something that's a lot more contextual, you would take that layer apart and then you would include lots of context resolution strategies that we'll cover in a minute. You can take if you want something that's a bit more, that can understand a bit more vague language, you can take apart the classification layer and then make it a little bit more kind of clever around how it understands language. And if you want something that can respond very contextually, so like answers stuff, interacts with loads of external APIs, works with different clients, then you want to use, then you want to take apart the skill layer. So there's 3 layers. Skill is a word that I've shamelessly stolen from Amazon because they use the Alexa skills. So yeah. So context. Part 1 is all about noticing and kind of remembering things, making sure that the correct features are present and are available for context resolution. And when there's a conversation happening, all the details about the conversation are kind of persisted somewhere. So you can think of it in express terms or in terms of a website design or a web application development side of things. You can think of context as like some kind of session store. So it's a thing that remembers stuff and returns it when you need it. And it's a little bit more than session store because you may not want to eternally remember stuff. So you might want to, if a question was about like, tell me nutrition information about Apple, and if after 2 years, if there's another question that's a little bit vague, you may not want to remember that the person asked you about Apple 2 years ago, and hence after 2 years he still means that in the next query. So you may want to set like timeouts and kind of TTLs on your context store. That's where your context resolution strategy comes in, which can take into account like how you can take context and how you can apply it on a timely basis and how you can apply it on different inputs. So when I say this about noticing things, it's about feature extraction. So think of a question like quite an easy question. Tell me nutrition information about apples. Feature extraction there is you've got at least 2 features. You've got apples as an object, and you've got nutrition information as the actual main context. So the context is that you're asking nutrition information about apples. So if the following query is something like what about its calorie content, then it can then derive the object from apples. Context on its own, the out-of-the-box context implementation is basically just a session store where you can take stuff and put stuff back into it. There's no real interaction in it, but you can extend it to have those information. We've done it with one of the projects that I'll briefly talk about, which has a bit more advanced context resolution. The next bit is kind of remembering storage and retrieval. This is quite simple. it's like a context store. You can store stuff in an external store, or you can store it in memory. So it depends on how you want to scale it. You might want to think about how you want to remember stuff. Also, if you're storing it in an external store, you're going to have latency issues, and you might have to consider stuff like security and hashing of the actual IDs and stuff. Context, the main key of context is it links, everything in context links to the conversation ID. The conversation ID is normally created when you're starting a conversation or you're part of a conversation, and it's kind of persisted throughout. You might want to persist conversation ID for the user ID, because you might only get one user at any given time interacting with the chatbot. But ideally, you want to create a new conversation ID every time a conversation is kind of initiated. And as I found the hard way, you might want to make that conversation ID itself expire when that conversation isn't active for more than 20 minutes or so. The next bit is classification. So this is the kind of the middle tier. This is the actual brain of the chatbot. If you're working with anything that uses intelligence, so I think there was a Valo workshop yesterday for hackers. They were talking about a possibility where they can hook Valo in with a chatbot. What you would really hook into with Valo is the classification piece, where you would make it talk to the actual brain of the chatbot, not really the context or not really anything else. Because what you really want there is, with your events coming in, you want to classify things into multiple topics, features, or classes, and then get that information out into a different stream or into something else. The idea with classification is quite simple. You take input and you produce multiple outputs. So it's one or more outputs. It looks really complicated. So when I started learning this, all the articles that were on about classification made zero sense to me, because they were all talking about complicated equations. And I had no idea how a low gradient search works. But in a nutshell, in classifier, you can write a very simple classifier. I wrote one the other day that I'll share a link to at the end. It's a keyword classifier. Essentially what it does is it looks for multiple keywords in a given sentence and extracts features out of it. So the idea is if it finds the word apple inside your query, it will extract two features, apple and fruit. If it finds something like Shiraz as a wine, it will extract two different features, Shiraz and wine. The reason why I keep saying two is because one of them is a feature and the second one is a class. So the class is the classification of the object, and the feature is the actual object itself. The topic is really the subject of the sentence. So what are you talking about in that particular sentence? The idea is, in the classifier, what you're doing is you're mapping inputs into topics, and then you're then mapping topics into skills. So you're then saying, if the topic is this, or is any of these topics, then execute this skill. So a skill is basically a piece of code they are executing. So the idea with the skill is basically this. So given required context, topics and features, do something and then return a response. That's a very basic skill in a nutshell. Your skill gets executed, and then it returns a piece of data. That data could be a sentence or an object back that the interpreter can then work with. And then as part of that, it could be doing something a bit more concrete. So it could be an API call outside, or it could be doing a database records lookup or search or something like that. Also, skills are supposed to be atomic, so it's all or nothing. It returns the data or it doesn't. There's no partial response type. So the idea being that if a skill doesn't know what to do with a given information, say for instance, it was operating on a topic of ask nutritional information with a given feature of apple. If it somehow doesn't know what that means, if it somehow doesn't know what to do with that feature, it can reject the entire interaction, and it can say, I don't know what to do with it, which then goes back into the classifier, and then classifier will then try and look for a different skill. The idea is that the classifier is the kind of like the mediator between different skills. It classifies into topics, and the skill that matches the highest rated or the highest confidence topic is the one that will get executed. If that skill says no, it just goes down the list and it just tries next. So that's kind of the idea. In the classification, there's different strategies that we'll also cover in a minute, because you will find that one classifier isn't really enough for a lot of the applications that you might want to do. Does that make sense? Cool. The next thing is a deployment diagram of how it might work. The idea here is to try and decouple as many elements as you might want to from a chatbot. You've got your main framework here. That's just an example, but it could be your own implementation of the framework. You've got your classifiers that are externalized, in this case, into a separate EC2s. For those who've used Amazon services, you might recognize the icons. This is an icon for a load balancer. This is an icon for a server. And this is an icon for an API gateway. And that's an icon for a Elastic Cache, which is an Amazon store that you can use to store kind of session information inside like Redis or inside Memcache database. The idea here is you can take this apart. So if you don't like the way your skills are working, you can take those and replace them with like a web server or something like that, or a set of APIs. If you don't like the way your custom classifiers are working, you can replace these with IBM Watson, and you can change the adapter inside Talkify to work with IBM Watson. It works mainly on interfaces and contracts. Those who've done kind of like the backend development would know, like every time you start writing a service, it will begin with a contract, and that's what you're trying to do here. You're trying to establish contracts between things, and if those as long as those contracts are kind of satisfied from here, you don't care how all of this works. You're just interacting with it. So currently, I've got a interface for IBM Watson, which works with Talkify. I've got an interface that works with a natural language processing library. It's a library that works offline. It needs no internet. It uses logistic regression. For those who are data scientists in this room, might get a bit excited because it's actually quite cool. And it also has a custom algorithm based on naive-based implementation. So those are the offline ones. If those aren't your thing, you can make those work with an external one. It could be IBM Watson, it could be Azure. I've got one for Azure working in progress, but yeah. Yeah. So this is kind of how the implementation works. It's still a little bit complicated. It needs a lot of simplification, which is currently in progress. But as you'll see, it's just a normal NPM project. You're just initializing the project for a start. Install the library. You load the library, so that's loading documents. The idea here is that inside the actual bot implementation, you can pass in options for what custom classifier you want to use, what custom input method you want to use, what custom skills you want to use, what kind of strategies you want to use. So that's all kind of customizable. And in this case, it's gonna that is a chatbot that's going to tell you knock knock jokes and Chuck Norris jokes. So the idea here is you're first training the chatbot. Now, this is slightly controversial because you may not want to train it on kind of boot up every time, in which case you can just ignore that. A lot of the adapters for it, like the IBM Watson adapter, doesn't support training because you don't want to train Watson every time a chatbot comes live, because IBM Watson takes a lot of time. I think a couple of weeks back, I was trying to train IBM Watson with 20,000 input records across 5 topics, and that took 4 hours to train. So your mileage may vary depending on what you're trying to train it for. So in this case, we're just using the out-of-the-box algorithm, which is a logistic regression algorithm. Basically, what it does is it creates a graph for every topic, and it tries to so it tries to create a graph based on given inputs. It tries to create a graph for every topic. So we've got 2 topics, knock knock and Chuck Norris joke, based on those inputs. So depending on what the input is, it will plot those points into the graph. And the next time you try and ask it a question, it will take that input. It will decompose it into basically X and Y points, and then it will try and match it on the graph and see which of those graphs are the closest match to its input training set. And the kind of idea there is it also gives you a level of confidence. So what you can then do with it is you can create a loop that says if the confidence is more than 90%, then feed that back into it as a training data set. So it constantly keeps learning about new things. You can't really do that with IBM Watson because it's not as real time as you might think. So an alternative there is what we do with it is we just put it inside a database, and then it gets it goes into learning as part of its asynchronous batch process, which takes it all and then makes it learn again. So The next thing is just some custom skills. So the idea with the skill here is it's just so if you use Express.js, you'll kind of recognize this kind of syntax. Context is the context at the time for the given topic. Request is the idea, is the actual request object, which contains details about the sentence, about features, about classes. It contains all the information that the classifier has gathered about that given topic. That's your topic that your skill is subscribed to. So it's currently subscribed to the knock joke topic, which we trained earlier. And the response object basically allows the skill to respond. So it could do response.reject, or it could do response.send, or it could do response.lock. The difference between three is if you do response.lock, that tells the framework that you're locking your skill needs more information from the user, so it locks that conversation so that next time there's input that comes into the skill, it gets executed. It matches this exact skill, and it knows what to do with it. In this case, we're just basically sending a normal single-line message with a knock-knock joke out to the user. We've got the same thing with Chuck Norris API. Also, if you look closely, two of the skills have a name as a first argument here. This basically tells the framework to make sure that it logs that in case there's an error. If you're working on like an enterprise setting, logging is really important because it's part of auditing. Everything is auditable. So your logs are also auditable. So if something goes wrong, we have the logs that make sure that we not only know exactly what happened, but we also know where it happened as well. So it's not just about debugging, but it's also about auditing and kind of everything else, which is why that's quite an important thing to do. Also, the name is also used for locking. So when you lock the conversation, it will match that conversation, match the next input to that name, and it will try and match that skill to that name. So it will know exactly what to execute. You can do lots of different things with the name. You can do versions. So if you know A/B testing, if you've done A/B testing, you know that in that skill you can then do version 1, version 2, and then have it match one of those. But when you lock the conversation, it will make sure that if the version 1 of the skill locked it, the next time it will always go to the version 1 of the skill and not to the other version, because that would be silly. Yeah. And then basically what you do is you add the skill to the actual bot. There's an alternative argument that you can provide here to say to match a confidence level, where you can say if the classifier is not confident, or if the classifier's minimum confidence level is 80%, only then match this skill. That lets you do kind of like a what's the word? It lets you do different levels of skill. So you can say if the classifier isn't very confident, then execute my less confident skill. If the classifier is very confident, then execute the most confident skill. So it could be something like you can have so if you're trying to write a chatbot that's a coffee barista, then you can have two sets of skills that can say if the user that's asking me for a coffee is 80% confident, then execute this skill, which will just like straight away make an API call and then make my coffee. If the user is between 50 and 80%, then execute another skill, which may not execute the API call, but might just confirm with the user first to say that, okay, I think you meant that you want a chai tea latte. Are you sure? And then the user can then say yes or no. That's quite useful because instead of having ifs and elses in your skill, you are letting the framework make the decision on what's the best thing. And also it's incredibly useful for logging because, as we said, each skill has a name. So when you're logging stuff and when the framework is logging all the executions of different skills, you can know that which ones are being logged in more. So that way you can choose which part to kind of fine-tune a bit more and which part to not fine-tune. And then export the object. So that's just a standard JavaScript thing. So you'll realize that so far I haven't talked about Facebook, or I haven't talked about Google Home, or I haven't talked about Alexa. That's because the framework doesn't really care about what your input mechanism is. All of those are a input adapter to the framework, so you can use whatever input you want. You can use Alexa, you can use web sockets, or you can use command line. So that's what that file does. That basically executes a file that puts a prompt and then says you and bot. You can ask it a question and then bot will respond, and it will kind of manage all the print line stuff. So yeah, you can try that. We can't really try that because we don't have live demo, but we will have live demo outside. Cool. So we'll talk a little bit about the advanced concepts. So far, what we've got basically is a chatbot. We don't have an assistant, it's a chatbot. Think of a case where you are trying to develop something for people with mental health problems. You don't want to have a chatbot that asks them, do you have a mental health problem? Because that's quite a silly question. What you really want is something that initiates a conversation with that person with a vaguely guided flow that lets them extract different features out of those inputs that the person answers to the chatbot, and then eventually get a result out of it. So the idea is, if you're asking a person and if you're talking with them, and if you realize that they keep mentioning murder and kill, they're probably not very stable, and you might want to do something about it. So that's what these concepts will let you do. They'll allow you to expand what you've learned so far into a way that will allow you to write an assistant rather than a chatbot. And you can have guided conversations, you can have different kinds of stuff, which is really exciting. So the first step is to look at something called a quorum. The idea of a quorum is that if you have so far we only had a single classifier that was classifying things. And trust me when I say it, it's not enough, because a single classifier at most can answer like 10 different types of questions, or 10 different types of input topics. And that's not really enough, because if you're trying to build something that's really complicated, then you will have to have more than one. Each classifier, the idea here is that you group all your classifiers. You have each classifier specialized in a specific thing, and then when you group them, it will basically pass that input through all of them, and then whichever one of those input classifiers is the most confident, that's the one that wins that conversation. So each classifier will then say, like, I think this is about apples. I think it's about mental health issues. I think it's about it is about the weather. And then from that, the actual framework will then make a decision and say, okay, so that's the highest confident classifier. So I'm going to try and match a skill on that, and then try and do that. If the skill says no, it will just kind of let back out and then just not do it again. And they'll just go to the next. So it'll just keep going. So quorums are really useful, because that way you can use different types of classifiers and not use one classifier. I learned it the hard way, but IBM Watson is very expensive. It's actually cheap for the first classifier, but all the ones after are $20 a month per classifier. So it gets really expensive really quickly, so you may not want to use quorums for that. But the idea with quorums is you can use IBM Watson on one of the classifiers where you want really high precision and you want really high kind of like fidelity output. And you can use the normal classifiers, like the out-of-the-box ones, if they're good enough on the kind of like the other ones. So that's the idea behind quorums, where you can kind of mix and match different things. Again, because all the skills are logged, you can see how your skills are doing, what your throughput is, and what your accuracy is like, which is where you can then make a decision and say, okay, so this is quite an important thing. But that classifier isn't working very well because it's a keyword-based classifier, and people keep saying stuff that it doesn't match. In which case, you can then make a kind of decision and say, okay, I'm willing to invest $20 a month to replace that with IBM Watson, or with Azure Text linguistic understanding service thing. So this is kind of how it works. You take those two different classifiers and plug it into the bot. So you say classifiers and then an array of classifiers. Again, the classifiers can also log things as well. So these two classifiers log their accuracy and log their input levels. And then you can take those logs and then try and identify what's the best one. The pros is that you get a very accurate classification on a range of topics, as I mentioned earlier, and it gives easy out-of-the-box analytics. The only bad side is it could get really costly. So if you're using 5 classifiers full of IBM Watson, then that's like $100 a month, which could get really expensive. It's still quite cheap, to be honest, but depending on what you're doing, it could get really expensive. Right, so next thing is really exciting. This is classification graphs. This is working with some of the guys in data team. This is what we kind of came up with. It's quite a cool idea around that leverages some of the principles of kind of neural network based on like how you can layer things, but it's a graph, so you can do a lot more than just layering things. And the idea with a graph is you end up with something like this, which is absolutely beautiful looking piece of graph. The idea with a graph is you have different edges. And what you're trying to do is you're making your framework take multiple paths through the graph and then come up with a path. And a path is going to be a collection of topics, collection of features, collections of classes, and then you're then matching that path to a given skill. Then you're saying that, okay, if it's about food and about fruits and about nutrition information and apples, then it's going to match my skill that's going to talk about that. You can also match your skill and then say, okay, if it's about food and fruits, I don't care about the rest, just match me, and then you can do that. The graph, as you can see, each of these blocks are classifiers. The reason why they're different colored is because they're supposed to represent different types. So that's like an external classifier, that's like an internal classifier. And the idea is, again, that you can mix and match. So you can, because everything is based on contracts, you can say that that's going to be IBM Watson, that's going to be Azure, that's going to be AWS, that's going to be my custom homegrown one, that's going to be using something like naive-based algorithm to do that. And the idea is really to get those paths going, and then I have a path that matches a skill. The problem with paths that we found really quickly is they could mean different things based on what are you talking about, really. So you can have a path that's like from food, fruits, to nutrition information to apples, with the average confidence or the average strength of the path being like 0.6. But it's still a really long path. So it does mean that it has kind of resolved it, but it's just not very confident about it. And it could mean that the path from food to fruits is very confident, so it's like 100% confident, but like from fruits to nutrition information is like, there's almost like 10% confidence, but from that to that, then you have quite a high confidence. So it's a little bit of a mix and match type thing. And this is kind of where you can use something like a skill resolution strategy. This is where you're trying to provide a custom algorithm that tells the framework what kind of resolution strategy you want to use, what's your if you want to be kind of selective, or if you want to be like additive, and this is what it looks like. So selective is where you're picking certain things out, and then you're kind of basing your decision on that. Additive is when you're collectively making a decision, considering everything in the path. So this example about the knock-knock joke is one of those. You get a joke, and then you've got different descriptions of those. So it could be a knock-knock joke, or it could be a Chuck Norris joke. And then you can try and match something with like politeness, and then say, okay, was the user really polite when he was asking me about this, or was the user really rude? And then try and execute a skill. So you can, if the user is rude, you can answer back with like a rude joke. If the user is really polite, then you can answer with like a polite joke, or you can kind of mix and match. So you can have so that lets you build a framework. That lets you build a chatbot that has a personality, and not just kind of like just a bland chatbot that answers to just answers statically to all questions. And also, like, it also lets you play with lots of the paths there, because you can then say, if it's a joke, Chuck Norris, polite, and maybe it's something about cat, because you can go up the chain, because it's a graph, remember? I shouldn't have put the arrows there. So you can go up there. So then Chuck Norris cat joke would be a good one there. I'm not sure if there are any. I'm sure there are. So that's it, I think, for the presentation. Thank you.